Good afternoon, class. We are looking at Chapter 2, Limits, Section 2.1, Limits of Sequences, Part 2. Recall arithmetic and geometric sequences. An arithmetic sequence is in the form of a sub 1 plus d, and we continue indefinitely, where the difference or distance d between consecutive terms is constant, can be defined by recursively a sub n plus 1 is a sub n plus d, or explicitly a sub n equals a sub 1 plus n minus 1 times d. So we are adding 4, 1, 5, 9, 13, and so on. Similarly, a geometric sequence, a sub 1 times r, a sub 1 r squared, and so forth, where each term is r times the previous one, can be defined recursively. A sub n plus 1 is r a sub n, explicitly a sub n equals a sub 1 r to the power of n minus 1. R is the common ratio. Example, 1 times 4 is 4, times 4 is 16, times 4 is 64, and so on. Now, in many cases, instead of a sub 1, we just say a, in which case becomes a s sub n. If we want to add them up, a plus a times r plus a r squared. We are looking at this one. We are replacing a1 with a. And this is the sum. And if r is between -1 and 1, the sum becomes a over 1 minus r. We've discussed this. We've seen it in algebra. And I'm going to quickly go over that here. So you're not responsible for the proof, but it helps to see how we arrive at it. So speaking of the geometric series, a plus ar plus ar squared all the way to the end, we can write it as a summation. This is a summation sign, sigma n going from 1 to infinity, a r to the power of n minus 1, and a, the first term, can't be 0. So if we want to look at the first n terms, so we call it s sub n all the way to n, we stop here. Let's multiply both sides by r. So it becomes r s sub n. This becomes a r squared all the way to the n. This one becomes a r to the power of n, because r, a r to the power of n minus 1 times r becomes a r to the power of n. Let's subtract, in other words, s sub n minus r s sub n. That means we are going to say this minus this. That's what we want to do. So the first term here remains because we don't have a here. We don't have a here. But ar is here, and we are subtracting. Ar squared is here, all the way to ar to the power of n minus 1. In other words, these cancel out this. This is left. This is left. We get a minus a r to the power of n. Left side, we can factor s sub n out. Right side, we can take a out. And if we divide by 1 minus r, we get s sub n equals a times 1 minus r to the power of n over 1 minus 1. So that's what we have seen. Now, if we go indefinitely, s sub n, summation n going from 1 to infinity of that becomes the limit of this expression as n goes to infinity. When r is between -1 and 1, r to the power of n goes to 0 as n goes to infinity. So in that case, when r is between -1 and 1, what happens? A over 1 minus r, this factor can come out. We get the limit of 1 minus r to the power of n as n approaches infinity. As you know, 1 is a number becomes 1. This goes to 0 because r to the power of n, if r is between -1 and 1, goes to 0. So 1 minus 0 is 1. We are just left with a over 1 minus r times 1, or simply a over 1 minus r. So that's the proof, everybody. Now, we want to use that for some applications. For example, here we have 1/2 plus 1/4 plus 1/8 all the way to the infinity, and we are going to add them up. Recognize this as a geometric sequence, adding them up meaning geometric series. Recognize, obviously, the first term is 1/2, a is 1/2. But what about r? Notice, if you multiply this by 1/2, you get 1/4. By 1/2, you get 1 over 8, and so forth. That means not only a is 1/2, so is r. Now, it doesn't matter that it's 1/2. What matters is that r is between -1 and 1. Or you can say between 0 and 1. Therefore, this sum is a over 1 minus r. So a over 1 minus r results in 1/2 over 1 minus 1/2. Also 1/2, the answer is 1. So very straightforward, everybody. Express 0.46 bar as a rational number. We've done this in algebra in a different manner by setting it equal to x and taking it from there. We are going to look at it from a geometric series point of view, understanding 0.46 bar. It's a repeating decimal, means 0.46, 46, 46, indefinite. That's the meaning of it. So we can write this part as 46 over 100, or 0.46. This part, we can write it as 46 over 10,000, or 100 squared, or 0.0046. And this part, we can write point, and we put 4 zeros, then 46, or 46 over 100 cubed, or 46 over 1 million. So I'm going to write it in both ways, fractional format as well as decimal format. First thing first, we notice this is a geometric series. If it's a geometric series, what is the first term a? This one. So you can say it's 46 over 100, or 0.46. Everybody knows this is 23 over 50. I don't want to go with the simplified version yet. I just want you to see where everything comes from as we work on. But notice this one versus this one, or this one versus this one. It's easier to look at the fraction. This is obviously 100 times larger than this. If the denominator is larger, that means the fraction is smaller by a factor of 1 over 100, or 0.01. So a is the first term, fractional format or decimal format. R is 1 over 100, or 0.01. And because it's between -1 and 1, we're going to go with the easy way out, a over 1 minus r. So we are going to write this sum is a, that means 46 over 100, over 1 minus r, that means 1 over minus 1 over 100, in the form of a fraction. Or instead of that, we're going to put 0.46. Instead of that, we're going to put 1 minus 0.01. So if you want to go with the fractional format, you have 0.46 in the numerator, 1 minus 0.01 in the denominator. And I'm going to finish this off later. But for now, If you want to go with a fractional format, so that's a decimal format. This is a fractional format. It's a complex fraction. We're going to multiply the top and the bottom by 100. This product is 46. This product is 100 minus 1, 46 over 99. If we go with this, it's 0.46 divided by 0.99, which is identical to 46 over 99. It can't get any more simplified, and you're done. What about 5.75 bar? We want to express it as a rational number, as a fraction. That's the concept. Well, it's 5.75, 75, 75, and it continues indefinitely. Which means is the sum of 5 and this part. Five plus 75 over 100 plus 75 over 100 squared plus 75 over 100 cubed, or in the form of a decimal, 0.75 here, 0.0075 here, 0.000075 here. So again, this part is identical conceptually to the previous one. We're going to work on it. So we're going to write 5.75 bar is 5 plus 0.75 bar. And that uses a over 1 minus r, because the first term is this, 75 over 100 or 0.75. And r is the same r as the previous one. Notice this is 100 times larger than this. So the fraction is 100 times smaller. So r is 1 over 100 or 0.01. Because this number is between these two, -1 and 1, we are going to go with the easy way out. So we're going to write 5.75 bar is 5 plus 0.75 bar. And 0.75 bar is going to use this one. To get to the answer. So 5 plus, now this part, if we go with the fractional format, a 75 over 100, and the denominator is 1 minus 1 over 100. If we want to go with the decimal format, this is 0.75. This is 1 minus that, 1 minus 0.01. We're going to take it from there, everybody. Now, again, let me just write the decimal format down here somewhere. The decimal format is 0.75 over 1 minus 0.01. But the fractional format, we multiply the top and the bottom by 100 because it's a complex fraction. This will give us 75. Let me use a different color. This will give us 100 minus 1. So we get 5 and 75 over 99. This fraction, the top and the bottom are divisible by 3, becomes 25 over 33. And if you want to write it in this format, is absolutely fine. They may want you to write it as a fractional format, only improper format. You have to multiply 5 by 33 and add it to 25. You get 190. over 33. However, if we go here, this is 0.75 over 0.99, and this is identical to 75 over 90. Recursion for medication, we remember the geometric sequence, the geometric recursion. Example, B7 is 3 times to the power of n equals 0, 1, 2. Just something we have seen. If you replace the n with 0, you get 1 here, so you get 3. 1, you get 2 times 3, 6. 2, you get 4 times 3, 12, and so forth. This is the basic geometric sequence we are familiar with. And clearly, with the formula B sub n is R B sub n, or 3 times 2, 6 times 2, and so forth. So the first term is 3, and R is 2, the common ratio. So we write B sub n plus 1 is R B sub n with 2 B sub n, A equals B sub 0 equals 3. Again, in some texts they use A, in some texts they use B sub 0, and so forth. Let's modify the geometric recursion by adding a constant term C. In other words, this one we want to add a C. So this difference equation arises for many real world examples, such as when a patient is given some medication on a regular basis, daily or so, and it becomes B sub n plus 1 equals R B sub n, and we are adding a constant. In this case, R is the percentage of the drug that remains in the body, where C is the fixed amount of the drug that is given to the patient at a specific time step, every hour, every 4 hours, every 8 hours, every day, every week, every month. Therefore, B sub n plus 1 becomes R B sub n plus C, and the solution is the same solution as here, B sub 0 or A R to the power of n, and we add this one, this factor of C times 1 minus R to the power of n over 1 minus R, and as always, if you replace the B sub 0 for A, you'll get that. And I have the proof at the end if anybody is interested. Let's look at a very simple example. We want to solve this difference equation where B sub n plus 1 is 0.8, B sub n plus 4, and B sub 0 equals 5. Remember, this is not necessarily dealing with the patient, because B sub 0, in the case of a patient, it's always 0 unless otherwise mentioned. But it's similar to that. So having said that, we want to look at this, everybody. Compare it to this. Ultimately, you have to memorize these formulas. But for now, we can use that. So B sub n plus 1 is R B sub n. So clearly, R is 0.8 plus lowercase c is 4. And B sub 0 or A is given as 5. So now you want to write this given. This is important, everybody. Write the given. And now, in this formula, just plug in the given. When you write the given, it makes it easier. So you're going to write B sub n is B sub 0 or A, which is 5, or 0.8 to the power of n plus lowercase c 4, 1 minus R to the power of n over 1 minus R. In both cases, R is 0.8. So that's how you handle it. Now, how do we simplify this? Because we want to get this ready for the next step, which is the limit. So here's how you deal with it. This one, 1 minus 0.8, 0.2, you put it underneath 4. And this is the same as 40 over 2 or 20. So this is what you have. Now, please understand that you can treat this as x. So 20 times 1 minus 20 times x. So 20 times 1 is 20. And 20 times minus x is minus 20x. Now this piece and this piece, they are like terms. 5x minus 20x is minus 15x. So you have 20 minus 15.8 to the power of n. If you think of this as x, so you have 20 minus 15x. The reason we write it, so the final step, that is taking the limit, makes life easy. So we are going to take the limit of this expression. So we use the limit laws. We separate them into two pieces. Limit of the first piece minus 15 times the limit of the second piece. And this is 0.8 to the power. And this is 20 minus 15 times 0. Why is that? Remind you that the limit of r to the power of n as n approaches infinity is 0 if r is between 0 and 1. What is r here? 0.8, the base. And so 20 minus 15 times 0, this is 0, so the answer is 20. It's very straightforward. So this was a general example. Now let's apply it to patients in general and medications and so forth and see what happens. A patient is injected with the drug every 12 hours. This is the time step, everybody. That repeats 12 hours, again 12 hours, again 12 hours. And it doesn't enter the formula that we have here. Concentration will be reduced by 90% before each injection, and the new dose increases the concentration by 1.5 milligrams per milliliters. What is the concentration after 3 dosage? Write the expression for C7 plus 1 in terms of C7. First and foremost, please understand here, when you look at these formulas, we have B, but we want to make it into C, capital C, because of the word concentration they are using. That's what they want us to do. So B becomes C, capitals. Don't mix them up with the lowercase c. So let's see what is given. We are dealing with the patient. So B sub 0, we're going to call it C sub 0, or A is 0. To begin with, patient doesn't have any medication in their body. So B sub 0, we're going to call it C sub 0 equals A is equal to 0. Or is the amount of medication that remains in the body before we give the next, dose. Concentration will be reduced by this much. So what is left? 10%. 1 minus that. 1 minus 0.9 is 0.1 is left. And how much do we give to the patient on a regular basis every 12 hours? 1.5 milligrams per milliliter. That's lowercase c. So write the given first and foremost. Now, here's the table. Obviously, the first dose is 1.5. We want 3 dosage. What is the second one? Again, we give him 1.5 and then 0.1. 10% of this remains. That means 0.15 and 1.5, 1.65. Then what? Again, 1.5 and then 10% of this, 0.165 gives us 1.665. So it's very straightforward, everybody. So that's the table. If we want to go with this one, C sub n plus 1, take a look at B sub n plus 1. Change this to C. B changes to capital C. Okay. And now that we have the formula C sub n plus 1 instead of B sub n plus 1 is, instead of R B sub n is R C sub n plus C. Now go back to the given and replace it. So C sub n plus 1 is R 0.1, C sub n plus lowercase c 1.5. So very straightforward, everybody. Now, if I start with n being 1, 2, 3, I get those. When n is 1, okay. Then this would be the 0, and 2 and especially 2 and 3 will work out really nice here. In any event, find the formula for C sub n. So we go back here and we look at B sub n, and every B changes to C. So this becomes C sub n. This becomes C sub 0. And now we go back to the given. This given will really help you speed up the process. So take enough time to write the given. So we are going to replace the C sub 0 with 0. Or here, here, and here, all of those with 0.1 and lowercase c with 1.5. Obviously, this goes to 0. 1 minus 0.1 is 0.9. We put it underneath 1.5. This is 15 over 9 or 5/3. And again, if you try n equals 1, 2, 3, you get the same answers that you got in this table. And eventually, we want to find the limit. So we want to find the limit of this expression, everybody, as n goes to infinity. So when we take the limit and we use the limit law on that, we can take the 5/3 out. The limit of this minus limit of that as n goes to infinity, and we know this is 1, minus we know this is 0 because r is 0.1. Remember, it's between -1 and 1 as n goes to infinity. As n gets larger, this gets smaller, and as n goes to infinity, it goes to 0. So 5/3. And now you use the units, milligrams per milliliters. And what does it mean? Therefore, regardless of how long the treatment continues, the drug concentration will never exceed the limiting value. And that's what matters. That's what's important, everybody. A doctor prescribes a 100 milligrams of antibiotic tablet to be taken every 8 hours. Just before each tablet is taken, 20% of the drug present in the preceding time step remains in the body. How much drug is left after the third tablet? Write the expression for Q sub n plus 1 in terms of Q sub n. First and foremost, the moment you see Q here, that means every B must change to Q. Okay, that's how they want it. Now let's read and write the given. So a doctor prescribes 100 milligrams of antibiotic every 8 hours. That means 100 milligrams after 8 hours, again and again and again and again. So this is the lowercase c, 100. We are dealing with a patient Q sub 0 equals A equals 0. So B sub 0, we're going to say Q sub 0 equals A equals 0. What is left in the body? 20% remains. So that's R. You don't have to do anything to that. Now here's the table, and we start with 100. Then over here, every 8 hours, we give him 100. So we give him 100, and then 20% of this, it's 120. Again, we give him 100. 20% of this is 24. With 100 is 124. So pretty straightforward. Now, as far as this one is concerned, we go to this formula and we change the B to Q. And then we go to the given, replace the R with 0.2 and lowercase c with 100. And we get Q sub n plus 1 is 0.2, Q sub n plus 100. And again, with 1, 2, 3, we can make up this table. We want to find the formula for Q sub n. Here's B sub n. So change the B to Q. So everything here. So B sub n becomes Q sub n. B sub 0 becomes Q sub 0. That's it. Now, again, see, that's the beauty of the given. It makes life easier. We're going to change the Q sub 0 to 0. Or here, here, and here. changes to 0.2, and lowercase c changes to 100. This goes to 0, 0.8, put it underneath 100. 100 over 0.8 is the same as 1000 over 8, which is 125. And now, again, if you do 1, 2, 3, you get the same answer here, everybody. And we do this to get it ready for the limit. So we're going to take the limit, everybody, of this expression. When we do that, we apply the limit laws. We take this one out. We take the limit of the first one minus the limit of the second one. And this is 1. This is between -1 and 1 goes to 0. So you get 125, and you write the units milligrams. You have to write the limits, everybody. What does it mean? Let me erase my work so I have enough room. Therefore, regardless of how long the treatment continues, the drug concentration will never exceed the limiting value, which is 125 milligrams, and it has proved to be safe for the patient. That's important.